is equal to F minus D over D. Let's do it their way. We are using S's and stuff, right? And so it's S minus. So just here's what you're basically doing. So what's the magnification going to be here? D equals S equals F. All right. So I'm looking at this. So it's 10 over 5. So it's minus 5, but I don't care. I'm just looking at relative. So it's 10 over 5. So I've got a magnification 2. So they give you a whole bunch of those. That's how you look at it. Just make a little list of the table of F over the S minus F, and just find out whichever one's bigger is the bigger magnification. And yeah, if you care. What I did was I multiplied everything through by S prime. And I know that this is basically my, I knew this was my magnification. I took this onto this side, and I just got a common denominator, and then I inverted it. That's how I got that. It's not that big of a deal. It's not something I would ever have you memorize, but this homework question, it needs you to do it. And rather, you can do each one of them by plugging into this equation and solving, but that seemed tedious to me. So instead, what I wanted you, I thought I'll just give you kind of a leg up, and we'll see where it goes from there. Next in line, we were given that F is equal to negative 20 centimeters. What have I just learned? We're going to get, so it's a convex mirror, so everything's going to be virtual. Do I expect any S's, any S primes to be positive? No, I expect every S prime to be negative. So they give me a bunch of distances. Your check is, do I get negative every single time? I also expect that my magnification, which they ask for, will never be as big as 1. Everybody with me on that? So it's always going to be a number that's less than 1. All right, so whenever F is negative, all S primes are negative, and all M's are positive and less than 1. All right. Now, I'm given that an object is 10 centimeters from a concave mirror that has a focal length of 7. Listen. 10 centimeters, focal length is 7, concave. What can you tell me without doing any calculations at all? Oh, your hand was up. That's dangerous.
What was that?
All right, listen again. I'm 10 centimeters away from a mirror that has a focal length of 7, and it's concave. So first off, what kind of an image am I going to get? A real, because I'm outside the focal length, and it's a concave mirror. All right. So, all right, we can do that. And so they have me do a bunch of calculations. They tell me to find S prime, and then they give you a range of different distances. So you just have to go from there. Trying to think of the time that I have. Most of these are just actually cranking the same kind of stuff over and over. All right, so I think I'm going to wait till. So please look at those before Friday, and I'll go over them with you. So at this part, I need to sort of just back off and do just a few, last minute kind of concepts about what we're doing. So we're throwing a lot of words around. When I'm talking focal length, what does the positive and negative mean? Positive focal length means real image, which means it's going to be upside down. What kind of a mirror gives me a positive focal length? Concave, because the center will be in front of the mirror. Mirrors can only reflect, right? So it'll be in front. All right, and so when I have a concave mirror, does it make real or virtual images? Both. Can I get a magnification bigger than 1? For concave? Yes. Both virtual and real can be bigger than 1? Yes, because when I'm right at the focal point, I get enormous S prime positive, and as soon as I cross in, I have still enormous S prime negative. So yes, I can get very much larger than one for both real and virtual, and on in. When I have a convex mirror, that means that F is negative. And so the only kind of image I can get from a convex mirror is virtual. And it will always be smaller than the object, always. Hence, objects in this mirror may be larger than they appear. Right? All right. And so S being positive means what? I have a S represents what? Object. So a positive S tells you I have a real object. And those are the types that we tend to have in this world, are real objects. All right? Virtual objects, it takes more than one lens or mirror to do, and we're not doing that. Right? If I have a positive S prime, it means it's a real image. What's a test of whether an image is real or not? Okay, you can do mathematical, but you can put it on a piece of paper and look at it. All right, so if you took a magnifying glass and held it up to this window, I would see an image of outside on my piece of paper right here. Have y'all ever done that with a magnifying glass? Do it. So get in a room that's kind of dark, has a window, get a piece of paper, just move it back and forth, and you get a perfect picture of the window on the paper. But it will be upside down because it's a real image if I'm seeing it, and therefore it has to be upside down. Yeah, you can do, yeah. All right, and then, so we got positive and negative S, positive, negative S prime, positive, negative F. Positive M means what? Upright. So a positive M, the magnification is so that it's upright. Now we use the word magnification, but that does not always imply that it is actually being magnified. It just means that the image may be a different size than the object. All right, so a magnification of 1 means the image and object are the same size. Anything else is different from that. So you have 3 things with positive and negative. F positive and negative, S and S prime positive and negative, and M positive and negative. They all have a different meaning, so work your way through that. Right? Learn what those positive and negatives mean. Before I kick you away, on any of this, do you have any questions? Do you understand the 3 ray diagrams and the 3 rays you have to draw?
Okay, for multiplication, is it negative S divided by S?
Negative S prime over S. Negative S prime over S.
So when you have a real image, your S will be positive and so will your F?
Yes. It took me a minute because that was a good question actually. I had to stop and think about it. Because if F were positive, then you could never get.
Yeah, okay.
Yeah, so yeah, you're right. All right. So practice, guys, practice ray diagrams till you get sick of them. Even like any of the homework problems, you can sketch them just to get used to drawing them because you are going to need to draw them on a test. And if you ask me about them on Friday, we'll be able to talk about them because you understand we don't target it. New material just keeps coming and we start doing different things after this. So I will see you then on I have all these leaky notes and I said there was no time to cover this.